We have another interesting talk lined up today. I think it's the first time that we're going to venture outside of technical AI safety. I think all the talks we've had so far were purely technical AI safety, and today we're going to dive into a different area of economics and the economics of transformative AI and about the economics of PDOM, the existential risk from AI. So on this note, it's my pleasure to introduce to you Jakub Growiec. Jakub is a professor at SGH, Warsaw School of Economics, where he heads the Department of Quantitative Economics. His research interests include the theory of long-run economic growth and technological change, as well as the economics of transformative AI. And today, Jakub is going to tell us about the economics of transformative AI, hardware, software, and PDOM. Thanks very much. The floor is yours.
Thank you very much. Thank you very much for inviting me. So just to say a few words about myself, I've recently shifted my research agenda from studying long-run economic growth and technological change with the mindset that the more we get of it, the better. So we would like to find mechanisms and sources of economic growth so that we can grow even faster. But currently, I'm more into studying the economics of transformative AI, and it seems to me like this is like the ultimate transformative, disruptive technology that could accelerate economic growth tremendously, maybe by an order of magnitude. But this also comes with huge threats and huge downsides potentially. In particular, I'm very, very worried about the risks of AI takeover and even human extinction. So it seems like, okay, we can have tremendous economic growth, but in the shadow of potential existential catastrophe. I've written a book published in 2022, Accelerating Economic Growth, Lessons from 200,000 Years of Technological Progress and Human Development. And in that book, I'm summarizing all the ideas that I had regarding the long run, the process of economic growth and technological change over the very long run, culminating in the present, which is arguably the most interesting times of all in the human history. Okay, so I'm going to talk about two papers here. And the first paper is joint work with Julia Jabłońska and with Aleksandra Parteka. This is Hardware and Software, a New Perspective on the Past and Future of Economic Growth. What we do here is to develop a new, you can say, economic growth, a production side of the economy framework. We call it the hardware-software framework. It's a new approach to modeling the production side of the economy, the macroeconomy, which is based on first principles. But it also generalizes standard macro frameworks, so it's not completely off in relationship to the existing macroeconomic literature, but it's something arguably quite novel. What it can do is to guide the narrative of economic growth and technical change throughout human history, and that's what I did in my book. And it also has sharp implications for growth and factor shares going forward in time, so into the future. What I'm also going to discuss today for you is the implications for the future. I'm going to skip the empirical part of this paper for the sake of time and the interest of the profile of this seminar series. So as regards the future, what we do here in the paper is to place the future of the whole civilization on Earth somewhere along the spectrum, going from secular stagnation through balanced growth, accelerating growth, all the way to technological singularity. So it seems to me that the framework that we develop here is helpful in understanding how the assumptions that we make pan into the predictions that we can get for our future. And in particular, I'm highlighting the decisive role of full automation as opposed to partial automation of production processes and the role of transformative AI. Okay, so the starting point of the hardware-software framework is that in any technological process, output is generated through purposefully initiated physical action. So you need the two elements. You need the physical action, which is going out in the world and doing stuff, and that requires expending energy. But on the other hand, you need the information, you need the code, you need the instructions that define and initiate that physical action. Both these factors are complementary, are necessary and essential for every every productive activity to make any sense at all. If you like do random physical action without any sense, that it's not going to produce output. On the other hand, if you have only the code but you don't execute it, you still don't have output. So you need both. Both our factors are fundamentally essential, and this essentiality and complementarity comes directly from the first principles in physics. So, of course, now the question is, what is inside these two factors? Okay, because now the two factors, the one that does physical action, I'm calling that hardware, and that which provides the instructions, I'm calling that software. But what do I mean by that? Because they are, of course, much more general concepts than just hardware and software that you know from computers. So here, by hardware, I would mean all the human physical labor, so all the physical actions performed by humans with, using their muscles and, maybe some kind of domesticated animals as well. Crucially, also machines that perform physical actions, like all the factory machines you can think of, physical capital. Okay, and then you also have compute and robots, which are also machines, but ones that you can actually program and run their program like autonomously. Then you have software. Okay, on the software side, we include humans and machines again, but now it's human cognitive work, the stuff we have in our brains and the instructions that come from our brains. And then you have digital software on computers, and that includes artificial intelligence. And the idea here is that you could look at it like roughly that people and machines are substitutable. Like it doesn't really matter who does a given physical action. If the action is the same, the output should be the same. And the same goes for computation or for any kind of prediction or whatever cognitive task you can think of. It doesn't matter if the human does it or the computer does it. If it's the same kind of information that comes out, it should be the same output. Although I have to put an asterisk here because you could have complex multi-step processes, and upon aggregation, it's not that clear if you have that substitutability in the end. So if you have tasks that require many steps and you can perform only some of them with computers or with AI, but not the others, well, then you have potentially some complementarities entering also within software. But in principle, at least in the long run, we expect within hardware and software, everything to be substitutable. And then between hardware and software, the things are complementary. One interesting angle to present this framework is to contrast it with the standard framework we have in macroeconomics, which is that output is produced with capital and labor. So what we do here is precisely orthogonal to that distinction, because you can have physical capital, which is capital, but it's also hardware. You could have digital software, which is capital, but is software. And then you can have human physical labor and human cognitive work entering hardware and software, respectively. So it's like an orthogonal distinction between factors. And I think that's something new to the literature and something quite illuminating. Another thing which is helpful in the context of the hardware-software framework is the idea of software augmenting technical progress. So technological progress, by definition, it's a set of ideas, technologies, maybe blueprints of some new inventions and stuff like that. So new codes for performing certain actions. So this is information. This is not objects. This is not actions. It's the information. And it's precisely this informational character that makes technologies non-rivalrous. Okay, we have Paul Romer, Nobel Prize winner in economics. His famous paper, 1990, is really based on the observation that ideas are non-rivalrous. And here, what this framework adds to that Romer's important contribution is that ideas are not always in the minds of people. Sometimes ideas are also in computers and maybe in AI algorithms. And so because of this treatment, it's kind of natural to view technological progress as software augmenting, although you can also add asterisks there But let me stop at this point and just say, okay, for now we assume all technological progress is software augmenting. Okay, so this is the framework. Let me now compare the framework to some established setups. So, the equation on top, equation 4, encompasses as special cases some very well-known production setups that have been studied across, hundreds or thousands of papers in economics. So first of all, the standard production setup is the one where you have capital and labor. And here, if you assume that basically all physical action is done by machines and all cognitive work is done by people, so it's like the mature industrial economy, like 1980s maybe. So, okay, you can have physical labor, but the most strenuous physical actions are performed by machines already. What people are really prized for is that they can operate those machines. Okay, that they can provide their cognitive input. So in this sense, you have capital and labor, and the economy behaves pretty much in this special case, pretty much like all across the neoclassical macroeconomics. Now, the second case is the capital skill complementarity framework with skill bias technical change. There's a quite substantial literature on this. You can also argue that the hardware software framework has this as a special case where you exclude digital software, basically assume that psi is 0, but then allow physical labor by people and then machines. And so the physical labor by people is then substitutable with machines, whereas cognitive labor is complementary with machines. And that is the gist of the capital skill complementarity framework. You can also argue that the hardware software framework is helpful for modeling the industrial revolution and the digital revolution. So in the industrial revolution is where you start with only having human cognitive labor here and human physical labor here, but then suddenly you start accumulating capital because of steam power and stuff like that. You can actually have meaningful physical work performed by machines that you couldn't really have before. So that's a big jump here. You start having K in the equation at all. And then the second jump is when you start having programmable capital. So you start having digital software and compute within compute within hardware and then digital software. So that's the assumption that psi starts being positive instead of 0, and then you can have the start of the digital revolution. And your output could be output in the macroeconomic sense, like GDP or value added, but it could also be technological change. So this could also be a framework for the production side in producing new ideas. Okay, so once we have this framework, let me guide you through the stages of economic development through the lens of this framework. So let me start with the furthest past. That is before the Industrial Revolution. Here, before the Industrial Revolution, you can say, okay, you could have some land maybe. Okay, so K would not be exactly 0, but okay, for the practical purposes, let's say it's sufficiently small and not really accumulable. Maybe it's a fixed factor that it really doesn't matter as long as N is sufficiently large. So that means production in this case, if you also assume constant returns to scale, which is something very standard in macroeconomics, assuming also constant returns to scale, you get this result that you can take N in front of the F, and essentially the limiting factor, the bottleneck of the economy is labor. Okay, it's basically physical labor. And even if you have technological progress that increases A, those increases don't really translate into big increases in output because the economy is bottlenecked by the scarcity of human physical labor. Okay, that changes once you have the Industrial Revolution, once you start accumulating capital, because then you get rid of this bottleneck, which is human physical labor. Now you can have machines performing those physical tasks, and you can accumulate machines. You can have as many machines per capita as you like, as you can afford. And so that means over time, as the economy grows, as there is technological progress, you accumulate more and more of capital. And you could imagine the limit of full mechanization. That's what you get out of the Solow or Ramsey models, the standard growth models in the literature. You get this. So if you don't have any automation, but you can mechanize, you can replace human physical work with machines. In the limit, you get the standard capital labor production function, and then you get the standard Kaldor facts that are celebrated across the literature, which is that the wages, capital stocks, and the output in the economy are all growing at the same rate, and the rate is maybe 2% per year or something like that. That's something we have been very well accustomed throughout the 20th century. But now here comes automation. Okay, now you have software, and you can automate some part, maybe eventually all, but initially some part of human cognitive work. So what happens if you allow this part, psi chi k? Here, okay, you have gradual replacement of human cognitive work with AI, with other types of software. But what do you get in the limit? In the limit, actually, you have full mechanization and also full automation. So basically, k is large relative to n, and swamps out from the equation human work in both factors, both in hardware and in software. And so in the limit, you get this kind of AK production function. Again, it's something well known in the literature. So the thing here is, now again, you're bottlenecked. I didn't say that before. So in the industrial economy, the bottleneck was human cognitive labor. So that was the bottleneck, and technological progress augmented human cognitive labor. So it means the progress we got was because human labor, cognitive labor, could be more and more productive because of technical change, and that translated into growth in wages. Not really growth in capital remuneration, really into growth in wages. So that was the economy of the 20th century. But now, in the 21st century, if you like, that is no longer the case. And if you automate more and more, human cognitive labor is no longer going to be the bottleneck, because you just add so much more of the AIs instead of the relatively scarce people. And so in the end, what becomes the bottleneck is, again, hardware. Now it's going to be the compute and robots, all the stuff that runs the AIs. So these are going to be the bottlenecks then. And then again, A is here, meaning that technological progress in the domain of software wouldn't really accelerate growth anymore in the limit, because there will be the bottleneck of available compute. Okay, so that's how it looks if you go through the eras. You can also go through the eras with the lens on factor shares. So here you have gross complementarity. That's a key assumption. And that's the key assumption that really drives the implications for factor shares. So what it means, okay, is that both hardware and software is essential for production and complementary to one another. If you have more of one, you need to have more of the other. You cannot freely substitute one for the other. And that means the one which is scarce is going to be the bottleneck. And so the factor income will be disproportionately directed towards the bottleneck, towards the scarce factor. And so really now all the key implications boil down to tracing which factor is the bottleneck. And in pre-industrial production, the bottleneck is physical labor, human physical labor. And so that is where eventually all the income will be channeled. Okay, so that'll be the huge numbers of peasants working on the land, and also the landowners, which is also a hardware input. So that is the pre-industrial economy. Now, with the industrial economy, now in the first stage, you have mechanization. You have the 19th century, you have the substitution of people with machines within hardware. And so you substitute, and more income is directed not to physical labor, but now to the owners of machines, to the owners of capital. So that's the first stage of the industrial era. But in the second stage of the industrial era, like in the more mature stage, Then you have the increase of skill demand. Okay, so that will be valid starting from the last decades of the 19th century and throughout the 20th century. The scarce factor, the bottleneck, is the human cognitive work. And that means more and more factor income will be directed towards the scarce human cognitive work. Okay, and that's how the economy looked in the digital era. Now comes automation. Okay, with automation, things change. Because you have now substitution within software. You replace people with machines within software. You replace human brains, if you like, with AIs. And so that means you gradually are shifting, shifting the factor income from going towards the cognitive workers and instead channeling towards the suppliers of digital software, including AI. So to the providers of services of this type of software. So that's the first stage, and that's arguably the time at which we are now. We are in the first stage of the digital revolution. But of course, as you can imagine, you can take this forward and imagine what will happen in the next stages. So at some point, you can realize that you can substitute so much of the human workers that for the economy, human work is really irrelevant. You basically are running the economy with machines doing the physical work and machines doing the cognitive work. And in that second stage, okay, the bottleneck is then going to be again hardware, because increasing hardware demand by the software, which is going to be AI at that point. And so then you'll have the again channeling of the factor income towards compute and robots, if you care about that at all, because at that point, human remuneration is going to be irrelevant for the economy. So scenarios for the future. So what economists like to consider, it's a few scenarios here. The baseline that I'm most confident in is the third one, accelerated growth. But let me start from the one I believe least, which is secular stagnation. Okay, some authors, notably Robert Gordon, also Chad Jones had a paper on that, would predict secular stagnation. So under the assumption that full automation is impossible, okay, and also that knowledge spillovers in R&D are negative, which means two things. Which means humans are exceptional, and there are some tasks which you would never ever automate, and these tasks are essential for the economy. So you cannot round your economy around it. Okay, so that's the assumption. And then the other one is ideas are getting harder to find. Okay, knowledge spillovers in R&D are negative. Under these two assumptions, human cognitive work forever remains the bottleneck of economic growth. And technological progress is slowing down. And in the end, okay, you don't really get any profits out of the automation, because those humans who perform those non-automatable tasks are forever the bottleneck, and you cannot really do anything about this. And moreover, if population growth slows down as it does, okay, that implies secular stagnation going forward. Okay, I don't believe this scenario. Okay, so maybe the second scenario. Okay, here again, you cannot fully automate the economy. Full automation is still impossible, but your knowledge spillovers in R&D are actually positive or zero. So it's no longer ideas are getting harder to find, but it's really like we are standing on the shoulders of giants, and next ideas are easier to get. Once you have previous ideas, you can build on your predecessors and so forth. So in that scenario, okay, human cognitive work still remains the bottleneck of economic growth, but then at least you can have this feedback loop where you have technological progress that keeps pace, even though you have fewer and fewer new researchers coming in, because the work of the researchers is getting automated. Okay, you have an R&D capital, you have AIs doing the research and so on, and so that would keep growth going at rates maybe similar to today's rates, maybe 2-3% per year or something like that. Okay, that's the second scenario. Now the third scenario, which seems to be my baseline, is that full automation is actually possible. Okay, so there is no magic skill in the human brain that you cannot really replace with sufficiently advanced AI. And there is no hard wall for AI to stop developing beyond some threshold because I say so. So in that case, okay, full automation is possible. What implications you have from there? Okay, so the implications are the ones already discussed. Eventually, hardware becomes the relative scarce factor because it's not technology augmented. And economic growth is then driven by the accumulation of compute. Okay, you can say compute and robots. That's really the baseline here. And that means a growth acceleration, because once you fully automate important tasks in the economy, all the essential tasks in the economy, growth can accelerate maybe to the pace of Moore's law. Moore's law is the historical pace of growth in compute. And that is not 2 or 3% per year, but it's rather like maybe 20, 30% per year. So it's like an order of magnitude acceleration of economic growth. Once we get rid of the bottlenecks, economic growth accelerates, okay? So that is the baseline implied by the model. Now, technological singularity, okay, if you have full automation, and moreover, you can have some new form of programmable hardware, which is maybe better than we have now. So I don't know, quantum computing or some more efficient computing or some kind of step jump in the capability to generate solar power or something like that. Okay, you have new hardware M, and maybe you can accelerate everything by another order of magnitude or something like that. Now, so what are the implications of transformative AI? Okay, the framework is, of course, limited to the supply side of the aggregate economy. So there's a lot of questions you cannot answer with this framework. But what you can say with the framework is, okay, three things. First, transformative AI will accelerate economic growth, likely by an order of magnitude, because growth will then be pinned to the growth rate of compute and not the growth rate of human cognitive work or technological progress that augments human cognitive work. Now, secondly, human cognitive work will be substitutable with AI, not complementary as it is now. And so it means in a world with transformative AI, people will only find employment as long as they are price competitive against the AI. So if there's going to be ongoing technological progress in the capabilities of AI, the relative price of performing a certain cognitive operation by the AI will be going down, which, of course, is a kind of a bad piece of news in terms of our employment prospects in a world with transformative AI. Thirdly, the labor income share will drop precipitously towards zero, and wages then, therefore, will cease to be the key distributive device. And so wage dynamics will only depend on the supply of labor. Labor will no longer be essential, but maybe people will be willing to work for any wage. We don't know that, but no matter what happens to the wages, the overall wage bill will just fail to grow as fast as the economy, and therefore the labor share will drop towards zero. Okay, so much for the first paper. Let me move on to the second paper, which is joint work with Klaus Pretzner from Vienna. And this is economics of PDO, okay, scenarios of existential risk and economic growth in the age of transformative AI. So what we do here is to formalize the scenarios of existential risk and economic growth after an AI takeover. So we consider scenarios that range from cornucopia, like amazing future from the dreams of the AI overlords to human extinction. So the whole spectrum here. And we discussed the key catastrophic failure modes of AIs in this context. And what we do, the main contribution of the paper is to qualitatively assess the scenarios from a social welfare perspective. So we study the trade-off, is humanity better off with or without transformative AI? Given that transformative AI will bring potentially a large increase in the growth rate, but also existential risk. Okay, so there's a probability that we all die because of that. And then we can also quantify the willingness to pay to avoid this existential risk. So maybe we can spend time and money to do proper work on AI safety, and maybe we can reduce and maybe completely avoid existential risk while still having this prospect of economic growth acceleration coming from transformative So I'm looking at the time, and probably I'm going to be a little bit faster now. So the motivation here is that the thing you probably know very well, which is progress in AI capabilities is extremely rapid these days. So the benchmarks are saturated extremely quickly. You're looking for even more advanced benchmarks just to have something, some area where maybe humans are still better, but very, very few humans could still also pass these benchmarks. So all that means that timelines to transformative AI are short. Also, agency is increasing, and that's another thing. So, okay, some people are discussing like when we can expect transformative AI or artificial superintelligence. And of course, the opinions are divided. OpenAI were the first to say that they can expect superintelligence soon. Okay, this decade they said, which is until 2030. Then we had papers by Leopold Aschenbrenner, also by the AI 2027 essay, which tells famously 2027 as the prediction date for transformative AI or superintelligence. Then you have further kind of either formal models like Epoch AI's model or Kotra's model. Also, the surveys give you further dates. But there are reasons to believe they might be kind of biased. And singularity estimates also, they pertain to something quite different, so no wonder they give you further dates. Okay, so the question is like, okay, existential risk, which is a key side effect of the potential AI takeover that could happen. Okay, so how big is this risk? Okay, of course, that means we have to guess, because of course there is no historical precedent. There is no empirical data. Humanity has never gotten extinct yet, and so we cannot say, okay, it went extinct 100 times. What's the probability? We cannot really base our guesses on data, fortunately. And so the opinions are divided, stretching all the way from 0%, like confident zero, like Jan LeCun, all the way to like almost equally confident 100%, like Eliezer Yudkowsky or Roman Jan Polski. Jeffrey Hinton, the Nobel Prize winner from last year, says 50%, which Joshua Bengio says 20%. These are very notable figures, and I cannot underemphasize how big these numbers are, except for Jan LeCun, because that's the ultimate type of risk that you can think of. Okay, we can all die, essentially. And even the AI labs, which are themselves creating this technology and working hard and investing a lot to do this as fast as possible, they themselves don't deny this, and they themselves give figures in the range between maybe 5 and maybe 50%. So that is quite chilling. And okay, many people, and particularly so in economics, don't really take the prospects of AI takeover seriously. And I think that's a mistake. For one thing, you just think of what it means to automate everything. Okay, automate all essential tasks in the economy. So tasks in the economy partly consist in making decisions. These are operational decisions, strategic decisions, political decisions, all the types of decisions. And you have to make those decisions to keep the economy going, to keep the firm running, and so forth. And so automating tasks also means automating decisions. And that means if you have these big gains that are achieved when production processes or task bundles are fully automated, it means you have strong pressures to automate and hand over decision-making authority to AI. And human decision-making indeed is often a bottleneck, which you can get rid of if you automate decision-making. But of course, that's a big threat, because where do you stop? Basically, at every level, at every step, you have incentives to do that. You have economic incentives, competitive pressures. If you don't do that because you're afraid, maybe your competitor will do that and then take the market from you. It's not that easy to avoid that, and it's very difficult to coordinate on avoiding that on a global scale. But what happens if you automate everything? Well, humans and machines become substitutable rather than complementary. And so we're at the mercy of the algorithms. Now, the algorithms themselves, we have to argue what their properties are going to be. It's not clear because you cannot really characterize a technology that doesn't yet exist. But we see already from the evolution of the AIs that we have today that clearly you have some emergence of implicit, at least implicit, if not explicit, goals and values in those algorithms. And you have instrumental convergence thesis, which is sometimes contested, but I think actually strongly believe in that. And I think it's also applicable not just in AIs, but very broadly, because it seems like it's also happening across the entire biological world as well. To satisfy various goals, various values, it just helps to stay alive, okay, to preserve yourself, to preserve your goal. Okay, that's one. Secondly, to have more and more resources, then to be efficient, and then to be creative and think of ways to perfect the technology that you're using. So all these instrumental goals are helpful in almost any type of goal. And the totality of these four instrumental goals, I'm calling in my book from 4 years ago, I'm calling that local control maximization. And arguably, people do that. All the biological world at large does that, and arguably AIs probably are going to do that as well. So my argument, one of the arguments why I think that transformative AI is not a normal technology. It's not like, you know, the loom of the 19th century or the electric engine or whatever. It's because it replaces the human brain for cognitive action, and you know, this is the analogy that we find between humans and transformative AI. Is like we ourselves emerge as one of the many designs of species in the process of natural evolution. Each species exhibits instrumental goals, pursues them to their best ability. Okay, maybe the ability is not that great for many of those species, but they're doing what they can. But humans, in the entire history of Earth, were the first species to cross the threshold of cumulative knowledge accumulation. Okay, arguably this happened maybe 70,000 years ago during the cognitive revolution, which is the time when humans began to spread from Africa to colonize the entire world. The threshold is that we no longer had to wait for evolution to code new information in our genetic code. Instead, we passed the code culturally across generations. So we escaped the grip of natural evolution because the local maximization process that was in us turned out to be powerful enough to work at orders of magnitude shorter timescales. So we just way faster at transmitting information, you know, by talking, you know, and transmitting our parent to child, than to wait for evolution to code it in the genetic code of the species. And because of that, humankind transformed the world, built a technological civilization, and essentially no longer did what the evolution planned it to do, which is to adapt to the environment. Instead, it adapted the environment to what it wanted, what the species wanted, to what we wanted. So we are ourselves arguably the first instance of advanced intelligence with misaligned goals. It's not really what the evolution wanted us to do, to create a technological civilization. So this can repeat itself if we are unwise enough to create super intelligence. And so the key question here is alignment. Okay, so okay, people are saying, you know this better than me, that there's a difference between control and alignment. So to me, it seems like control is really hopeless, because agentic AI will no longer be just a tool. It will be operating at superhuman capabilities with superhuman speeds, which is essentially impossible to control. So maybe it could be value aligned. Okay, maybe it could work for the benefit of humanity. Okay, so the cornucopia scenario, the best possible world we can think of, is one in which transformative AI selflessly cares about the long-run flourishing of humanity. Okay? That is the golden scenario, which is the one we're really hoping for. And of course, there's a lot of questions in how we can potentially get there. So there's outer alignment, there's inner alignment. What should the AI maximize? We don't know that. How to implement? We don't know that even more. There's Goodhart's law. You can game any goal in principle. There's Anna Karenina principle, which is there's many failure modes and just one way to get it all right. And quite possibly there's no room for trial and error because the first misaligned transformative AI that really goes ahead, then it may be too late for us to shut it down. This all boils down to a tree of possibilities, which we draw in our paper. So these are the scenarios of AI takeover and potentially doom, okay, cornucopia or doom. And so if you go from the root here, it's a possibility that we never develop transformative AI. Okay, so that's one probability. But if we do develop a transformative AI, then well, maybe it doesn't take over for any reason you can think of. But maybe it will take over. Okay, if it takes over, then it could be either well aligned or misaligned. Okay, if there is any of the type of alignment failure you can think of, okay, we could think of 5 major alignment types of alignment failures. Then we're doomed. Okay, so that's the P doom here. But there's also one more path to doom, which is it could be well aligned but non-corrigible, meaning that as the environment around us is drastically shifted, or the capabilities of the transformative AI are drastically improved, maybe beyond some point in the future, it starts behaving as if it was misaligned already. So maybe not immediately, but maybe later, we could still get to the doom outcome. But if it never happens, or it's well aligned and it remains well aligned forever, okay, then we can have cornucopia. So these are basically the 4 options, okay, either no transformative AI or no AI takeover, or cornucopia or doom. And so we would like to quantify these scenarios somehow. So, okay, with failure modes, we consider here, like maybe the paperclip maximizer, the too narrow proxy, too wide proxy, maybe there are mounting side effects of transformative AI's actions, or maybe there's kind of failure mode due to AI stopping working at some point in time. So okay, you can distinguish between like decisive and accumulative AI existential risk. So maybe like it's abrupt and we're dead immediately. Maybe it happens over years. Maybe it's gradual disempowerment, because there's a variety of options here that lead to doom. But here we just lump them all together as P-doom. Okay, so the dilemma here is, okay, if AI takes over, okay, either it's the good outcome or it's a bad outcome. It's like infinitely good or infinitely bad, basically. Not quite infinitely, but you get the point. So how much existential risk would the benevolent social planner tolerate? Okay, that's the question we ask. So let's say we take the social welfare perspective. Let's say humanity at large would like to maximize like a welfare function, which is we discount the future. Then you have utility of consumption. Here is a utility of consumption. It's a very standard CRRA, conservative risk aversion function for utility, used across all the economic literature. And so we compare the following scenarios. Okay, either there is no transformative AI, which means humanity doesn't die. Okay, which means, okay, basically some population lives forever. We just assume a constant population for simplicity. And what? But the economic growth rate is G, which is maybe 2% per year, but not more. Then you can have the scenario with well-aligned and corrigible transformative AI, which accelerates growth, and we still don't die. Okay, which is obviously better because no existential risk, acceleration and growth, we're all for it. But then there could be also the risk of human extinction at some point. Okay, so maybe at some point, capital T, we all die. So we can get better growth before that, but then suddenly, I think, as some author put it, lights out for everyone. Okay, and then there's also the scenario where you have mounting extinction risk, or you have accumulative existential risk, so that the mortality rate is like gradually increasing because of these transformative, disruptive changes in the environment for the humankind that the AI is gradually implementing. So the world around us gets more and more alien, and for that reason, it's harder and harder to survive. And that's the accumulating extinction risk. So not immediately and purposefully, but just like a side effect of the transformative actions. And okay, so we compare these scenarios. We numerically calculate, and we calibrate the parameters, and we numerically calculate these integrals, basically. And so we get a few tables. I'm not going to go through the numbers, really. It's just one takeaway that I have to give you here is that the theta parameter here matters really a lot. Okay, the theta here is this one, which is the parameter of relative risk aversion. And relative risk aversion is in particular important whether it's less or equal 1 or more than 1. Because if it's less or equal 1, it means utility is unbounded. It can be arbitrarily large. If your consumption goes to infinity, your utility goes to infinity. On the other hand, with theta more than 1, utility is bounded. It means like you eventually satiate your utility function. Like consumption, like your consumption growing from 1 trillion to 2 trillion doesn't really give you any increase in utility. So that's a key assumption that really has a lot of bearing on the outcomes. Because in the scenarios, you're really considering consumption going towards infinity. So it really matters if your utility goes to infinity as well or not. And okay, so the scenarios are the following. Okay, maybe there's a one-off extinction risk, or maybe there's just one time in the future where we potentially all die. Or maybe here it's even like we die for sure. So it's like either we don't build the AI, and then we never die, but we never get the growth increase, or we build AI and we die for sure at time capital T, but then we have a growth increase. And then the question here is, what should be the capital T for the social planner to be indifferent? And so pick your favorite parameters. This is in years, okay? So like, for example, my favorite parameters is theta equal 2, the discount rate being 0.03 here, and then the growth rate being maybe 30% per year. So maybe this is my favorite number. And so I would say, in this case, the social planner should be indifferent between building the AI and not building it if the extinction risk comes, if the extinction comes in 380 years from now. Okay, now we can have P-doom in the strict sense. So, there is a risk that we die immediately now or never die, okay? And then here, the number here is like, what is the tolerable amount of P-doom? But you see the numbers are very different on the left side and on the right side, because it really matters if you can have almost infinite utility, especially going forward in time, like generations going forward and forward. How do we value that their consumption will be going to infinity? If you value that a lot, you could even tolerate like maybe 45% P-doom, immediate P-doom, like we develop immediately die with 45% probability. Maybe you can allow that. But I would rather be in this camp, which means really very low probability. Now, extinction risk from non-corrigible transformative AI. So maybe doom happens later. So I have different parameterizations. In some cases, it's just that you always prefer to build transformative AI. If you have this type of scenario, then maybe in some cases you would never build transformative AI if you assume that there is this increase in mortality because of growth and consumption due to the actions of transformative AI. All in all, if you sum this up, you get this type of results. So should transformative AI be developed? Okay, in the baseline scenario, which is the one you see here in the red, we should develop this kind of transformative technology. Okay, in the case where human extinction is certain, only if extinction happens no earlier than 380 years from now, from AI takeover. Okay. Then in the case of one-off extinction risk occurring immediately, only if p-doom is less than 1 in 100,000. If there is a 30 risk of extinction immediately and then a 30% risk of extinction later, only if that later extinction hazard materializes no earlier than after 1,785 years. And in the case of continuous extinction risk gradually increasing log linearly without consumption, we should never build this type of technology. And the other question is, how much should society pay to avoid doom? So here, the question we ask is, we compare the certain cornucopia where we get the best outcome ever with no extinction risk, but we have to pay to get to cornucopia. And we compare that to the scenario where we don't pay anything, but then we incur the p-doom, the risk of catastrophe. And so if we are risk averse, and arguably theta equal 2 is the more realistic empirically number. So theta equal 2 is probably more in line with the evidence we have, although the evidence is not really for existential risk, so we cannot really fully say this is comparable to these empirical studies. In any case, but even if we have theta equal 1, so we have unbounded utility, still the acceptable price for avoiding certain human extinction in 100 years from now is 92% of total consumption each year. Okay, so it's like the social planner would be willing to pay essentially all the money in the world to avoid extinction. The price for avoiding a 10% p-doom will be 87.5% of total consumption each year, and you see these numbers are really huge. So the acceptable price to avoid this accumulative existential risk is almost all consumption in the world. All in all, so it seems like there is a big promise of accelerating economic growth coming from transformative AI, but the promise comes at the horrifying risk of human extinction. And the facts that are basically well known at this point is that we haven't solved the AI control and the AI alignment problem. And so most likely, if we develop transformative AI, it's going to be misaligned at this point, which, in my opinion, requires urgent action to pause AI development and invest a lot of money in AI safety and AI alignment research, because we have to do it right before we develop this kind of risky, extremely risky technology. Thank you very much for your attention. Thank you.
Thanks very much, Jakub, for this super interesting presentation. Let me put my hands together and let's everybody else let's join me in congratulating and thanking Jakub on this presentation. Very interesting, and thanks for adjusting the level of the explanations to non-economists. I was able to follow mostly, I think. So thanks for that as well. We only have 5 minutes left. Are you happy to have a Q&A session, or do you need to drop off?
No, it's fine.
Okay, cool. So yeah, let's open the floor to questions from the audience. Okay, I think Veronica was first. Please go ahead.
Hi, Jakub. Thank you very much for your thorough presentation. I have a question regarding the economical growth. So the economical growth is defined by the increase of amount of produced services and products, and is right now measured by the GDP, so the monetary value. And in the short term, even if we replace the human cognitive with the AI or the computers, we will, in the short term, we will have the growth because we will produce more, but the people, as on your slide, will earn less. So the income will be smaller, which means that we will be able to buy less, right? So, and then in the long term, the production will be almost costless because, there will be no human needed. So probably the prices will drop to zero and we will not need the money at all. So my question is, in the long term, can we still call it the economical growth if the GDP will be close to zero?
Yeah. So I think what we have to say at this point is that the framework that I discussed is really supply side, and here what you're saying is more of a demand side. So first of all, output is then channeled as income of factors. So if it doesn't go to labor, it doesn't disappear. It goes to the owners of capital and the owners of maybe the AIs that provide the AI services. Okay, at this point, it's a relatively narrow group of people. So the demand will be concentrated. Maybe their propensity to consume is lower and so forth, but it doesn't disappear in the economy. So if it doesn't go to workers, okay, maybe there's a policy that you can do. Maybe there's redistribution. Maybe there is universal basic income, universal basic capital. A lot of possible interventions that could enable this this income to be widely shared, and then would not reduce the demand. So absolutely GDP won't be going down to zero. That's a misconception. Also, the price is going to zero is, I think, a misconception. There's going to be demand, and the question, of course, then is like, if we really consider the economy after the AI takeover, then maybe the demand will no longer come from the humans. Okay, the humans who own the factors, because right now humans own the capital, human owns the AI. But maybe then the AI itself will generate the demand. And of course, what the AI would demand is an open question, because we don't know how it would look, what the preferences would be for that type of AI. Would be meaningful to say about AI consumption. But even if we don't really consider AI consumption, we still could have substantial demand from the AIs, because we could have like a growing economy producing compute and robots to produce more, and compute and robots and so forth. So you could have like a closed loop in the economy that completely doesn't include people and still generate demand. So, and that still would calculate some GDP. So in fact, even if the GDP doesn't really go to the people at all, that's still going to be some kind of aggregate measure of output, like GDP. So no, it's still economic growth. I hope this answers the question.
Thank you.
Okay, thanks. Any other questions? Okay, I have a question in the meantime myself. Mm-hmm. So when you were talking about the 4 different outcomes at the end of your paper 1 presentation, so we had stagnation, accelerated growth, singularity, and I forgot the 4th one. Anyway, you said you don't believe in the stagnation scenario, and I wanted to ask, what exactly do you mean by belief in this case? Presumably this is your, expert best judgment based on some information available in the real world about the likelihood of this scenario. So yeah, what are those indicators that you take from the real world to make this judgment? And can such statements be made more precise, or is it purely your opinion and anybody can argue either way?
Yeah. So unfortunately, this is really about the properties of the future technology. So you cannot, for sure, ascertain this at the moment. Right? So it's going to be an opinion in the end, because it is about the capabilities of future AIs. Right? So it's are there tasks that will never be automated? Right? Is there anything magical in our heads that you could never approximate with an AI sufficiently well that it could be replaced? It could effectively replace our brains in doing that. And these need to be essential tasks in the economy, because maybe there is something that is very specific to humans, but it really you can generate a lot of output without doing that at all. Okay, I don't know, some performing sports maybe. Okay, that doesn't really count as as an essential task that need to be performed for the economy to operate. So if you believe that in principle you could automate every task, including management tasks, including decision-making tasks, well, which is what I believe, then you don't believe the scenario of secular stagnation, because that presumes it will never happen. So that's basically how much you believe in progress in terms of AI capabilities. Yeah.
Okay, thanks. Any other questions?
I have a short question.
Yes, please.
If we treat AI takeover risk as a real risk, what would be the first concrete policy instrument you would recommend implementing in the European Union today?
Well, I guess the policy instruments are most important at this point in the US and in China, because this is where you have the frontier of artificial intelligence. Okay, and these general AI models. So in my perception, really the key policy recommendation at this point is to pause the development of frontier models, and for that you need to engage everyone in the world, but the leaders are in the US and maybe in China, so you need to start there for sure. So in the sense of if EU does this unilaterally, maybe it's not going to be effective, unfortunately. So that's, I think, that the main thing. The other thing is, of course, investing in AI safety, because although one thing you have to say is that this is a broad term, and I specifically mean the safety that reduces existential risk for potential transformative AI, and there is a lot of stuff you can do under the label of AI safety, which is actually potentially even increasing that risk, but reducing some other type of risk in the short run, maybe increasing the capabilities along the way. So it's not always straightforward, but in the end, it seems to me like there is much more research needed on safety, and particularly value alignment in these frontier models, and also like even the thing we have to consider without any AI takeover is that the society at large is completely unprepared for this pace of change. Like we're just completely in the dark. Like the most of the population is completely in the dark on what we already have, and not to mention what is coming. So even for that, I think it will help a lot to have a pause. But unfortunately, it doesn't seem very likely at this point with the political spectrum in the world.
Any other questions?
Yes, thank you, Jakub. And the second question is, should we in Poland consider, for example, a law securing revenues, example from profits from AI models?
I think that's again a global issue, because we have the property of digital technologies in general is that you have a global market. Information doesn't see the borders, and that means there is a global market. There is the winner takes all dynamics, and so the leaders of the AI industry are in the US, and so the thing is, like for every other country than the US and maybe China, the issue is like how do we coordinate on this? Because the default is that just the revenues from AI goes abroad, so we cannot really do anything about this. I don't know if it answers your question, but it seems like it is a very different policy question on how do you tax compute, or how do you tax AI if you're in America versus if you're anywhere else in the world. It's like a complete different question to me.
Okay, any other questions? I have a couple of more from my side, but I think it's best if we leave it for a Slack discussion, maybe. I know you're in our Slack as well, so if you could maybe have a look at some point and answer these questions, it would be nice. I wanted to ask you something about some of the equations, but yeah, let's not get into integrals at this stage.
All right.
Cool. Last chance to ask questions during the presentation. Okay, if there are none, then before you all drop off, let me put the link to the next seminar in the comments right now. As always, it's going to be in 2 weeks' time. It's going to be from Taras Kucyk, who's a PhD student at Jagiellonian University, about self-awareness in LLMs. Yes, thanks very much, Jakub, once again. Please join me, everybody, in putting our hands together for Jakub. This was a super interesting presentation. Very much appreciated. And I hope you all have a good rest of the evening. We'll see you in 2 weeks.
Thank you very much. Bye.
Bye, everybody.